Everybody watch, please. Okay, first of all, I want you to write the word standard right here. Here's our goal today. We want to be able to understand, graph, and analyze quadratic functions in standard form. We haven't done much analysis lately. That was what we did in Unit 2. But we're going to look at some graphs and figure out, hey, what are the important features here? What's going on? How would we describe these? And these have to be in standard form when we start with them. Okay? And we've seen standard form before. It's actually this format right here. It's not as graph-friendly a form. It's certainly not in vertex form. So let me make sure that I catch up with you guys and do this right. So this is going to be factor out of 2. We've got an x squared minus a 6x, and then I move this to the very end. That's going to be a 3. I'm going to take half of this. That's negative 3. I'm going to square that. That's 9. And then I figure out what actually happened on this side. When I added 9 on the inside, what I actually did is I added 18. So I'm going to, Jack? Subtract 18. So that's going to give me this. I need it quiet, please. Fellas? That's going to give me a 2 outside, an x minus 3 quantity squared right here, and then a minus 15. And I'm going to bring back the f of x here. This is in a nice graph-friendly form. We call this vertex form. The a in this case that we were talking about before is a 2. The h in this case is a 3. And the k in this case is a negative 15. So if we write down what the vertex is, the vertex on this one is the opposite of that number right there. So it's going to be 3 comma negative 15. And we could figure out a bunch of other stuff like what it looks like. Does it open up? Does it open down? Has it been stretched, shrunk, all that sort of stuff? But it didn't ask for that. Is everybody feeling pretty good about putting stuff in vertex form? We're good? Okay, so we're going to run through and just going to step by step, very slowly, show what we do when we put things in vertex form. So there are a couple of steps missing on this. And if you follow along with this, it's going to make some stuff that we do later on a little bit easier. So this is standard form right here. So we're going to take a quadratic equation, quadratic function, in standard form. So the a, the b, and the c. And we're going to take that and we're going to complete the squares. So this is what we call doing something in general. So there aren't any numbers here. We're just going to say, hey, we're going to represent these numbers, the coefficients and the constant, with a's, b's, and c's. So here's what we start off with. So the first thing we're going to do is we're going to put these guys in parentheses and we're going to save that constant on the end. We're going to factor out the a. So when I factor out the a, I divide out an a. That leaves a 1 right here, which is what we want. That leaves me with a b over a, whatever that happens to be. And I've just rewritten this. So I factor out the leading coefficient a. So I take that a out. And I would, of course, want to include the leading sign. Then what I do is I take half the middle coefficient. And this is what I was talking to you about yesterday. This is why it's probably better to think of this as multiplying by half rather than dividing by 2, because this is already a fraction. So if I take b over a and I multiply it by 1/2, that just puts a 2 on the bottom, okay? So this is b over 2a. Then what I do is I square that. So this is the b over 2a. This is half the middle coefficient squared. Convince yourself that that's half the middle coefficient, okay? Half the middle coefficient squared and put inside the parentheses. Everybody good there? Okay. Now what we have to do is the next part, which is a little bit more difficult. You have to figure out what did that actually do to this. If I multiply these together, I get a times b over 2a squared. That's this right here. That's how I compensate. So if I added that much here, I'd have to compensate by subtracting it on the outside. So what I'm going to do here is we're going to replace this and we're going to make this look nice. So where the k is, that's the old c minus how I compensated. So if I add that much, a times b over 2a squared inside, that's effectively what I did, then I have to subtract that on the outside. And I'm just going to replace that. This is the old add things in and subtract them out. Okay? And if we leave it looking like this, and I want to put it in vertex form, I leave the a sitting out front, and I've got to make this a minus, so I put a minus right there, okay? and it's going to be minus whatever that is. Okay, so minus minus would turn that into a plus. So opposite of this number right here, opposite of that number right there is where the vertex is going to be. So if I slide down here, now I do not expect you to get every single ounce of this, but what I do want you to think about is this. If I got it to look like this, if I got it in vertex form, let's match a couple of these things up. The x-coordinate of the vertex would be this right here. So the x-coordinate of the vertex would be the negative b over 2a. The opposite of half the middle coefficient. And I could find the y-coordinate. Think about this. If I know an x-coordinate, I can always find a y-coordinate by plugging it in. So if I plug that into the function, if I take the function and I plug in negative b over 2a, that will tell me what the y-coordinate is. So if it's in standard form, I can actually find the vertex by doing this. The h part of the vertex, the x-coordinate of the vertex, is going to be negative b over 2a. The y-coordinate of the vertex can be found by taking that value, that x value, and plugging it in. So all this means right here, this looks nasty. This part, ugly enough. The k part, that looks really ugly. All that means is take the x value of the vertex and plug it into the function. Okay? So what we've got here is a little formula that if you're given a function in standard form, a quadratic function in standard form, you can figure out the vertex just by doing this. Take negative b divided by 2a, that's going to be the x-coordinate of the vertex, and then take that and plug it into the function, and that'll give you the y-coordinate of the vertex. Some people like this, some people don't. I happen to not be a huge fan of this, but we're going to show you this because it is a standard technique. Okay, I like vertex form. I like the way vertex form works. I like completing the square and all that sort of stuff. But if it just asks for, hey, can you tell me what the vertex is? Okay, some people like this better. So here's the deal. This looks awful. It's actually pretty easy. So for each quadratic below, find the coordinates of the vertex, state whether it's a max or min, and then give the equation of the axis of symmetry. So this is our f of x. This is ax plus bx plus c. Now, I'm not going to do this all the time, but I'm going to write it down on this one. A in this case is negative 3. B in this case is positive 12. C in this case is negative 1. Now, would you look at the formula up above? And would you tell me which variables do we need? Man, that's loud. I think they turned it up yesterday. What do we need? We need b and a, and we need to know what the function is. Okay, so do we really need c? No. Not for the formulas, other than the fact that when you plug it back into the function, you better get the right c. C is part of the function to begin with. So here's what we're going to do. I'm going to write down negative b, so that's going to be negative 12 over 2 times a. So I'm going to physically write that down. That is h, that is the x-coordinate of the vertex. So this is negative 12 over negative 6, which ends up being 2. Okay. So check this out. The vertex is at 2 comma something. What is that something? I then have to take this and I've got to plug it in. So I'm going to take this and I'm going to plug in a 2 into the function. So this is negative 3, 2 squared, plus 12 times 2, minus 1. See that c does come into play there. So this is going to be, let's see, that's 4 times negative 3, so that's negative 12, plus 24, minus 1. So that's going to be, correct me if I'm wrong, but that's a positive 11, isn't it? Okay. Let's put a box around that. That's the vertex. Didn't have to complete the square because we kind of did up above. This is not a subtle point. Everybody take a look at this. The reason we have these formulas, fellas, the reason we have these formulas is because we basically completed the square in general. And we know that the x-coordinate of the vertex is always going to be negative b over 2a. So I've got the vertex. At risk of opening this up, Mason, what's your question?
Wouldn't there be a different, easier way to write k out as like negative b squared over 4a or something?
To write k?
To rewrite k.
No, because you have to actually plug it into the original formula. You have to plug it into the original function to get it. Okay, it's going to depend every single time on what the original function is. So your formula is, hey, take that and plug it in here. Okay? All right, the other parts of this, max or min? Crew, max or min?
Max.
Max. He is right. Somebody else. Crew, pick somebody else to tell us how you know it's a max. Pick somebody else. Jack.
Because it's a negative, so it goes down.
Negative coefficient. The reason here is A is negative, so it's going to open down. It's going to look like this. It's going to have a max. Okay? Let's see. Give the equation of the axis of symmetry. Megan, what's the equation of the axis of symmetry? That's the vertex. Which one of these do we need to?
Negative 2. Or
Positive 2. There we go. Okay, I love the smile and the attitude. There we go. We've got everything. We've got the vertex. We know that it's a max because we visualized that it opens down because A is negative. And we know the axis of symmetry is still x equals the x-coordinate of the vertex. So in this case, it's going to be x equals negative b over 2a. Everybody got it? Okay, done with that one. I'm going to draw a little wall right here. I'm going to give you a head start. I need the x-coordinate of the vertex. I need h. Negative b over 2a. Opposite of negative 12 is 12. 2 times a, that's just 2 times 1. So that's 12 over 2, so I get a 6. I can automatically start writing down what the vertex is. The vertex is going to be, vertex is going to be 6 comma something. The axis of symmetry is going to be x equals 6. I've already got that much. Now I just need to figure out what f of 6 is. I got negative 6. Is that right? Is that what you got? Negative 6? Because you get a positive 36, you get a negative 72, and a plus 30. So we get negative 6. Okay. Hey, Jack, will you call on somebody to tell us whether it's a max or min?
Dane.
Dane, max or min?
It is a max. No, min, guys.
You sure? Because they both start with M. It's a min. Okay, will you call on somebody to tell us how we know it's a min? Psi, how do we know it's a min?
Because it opens up.
Because it opens up, okay? Because A is positive 1, that means it opens up. So we've got that stuff right there. I did it in the opposite order, but that's totally okay. Any questions? Okay, flip the page over. Okay, we're going to do one more problem. These are quadratics in context. We're going to end up doing a ton of these before we're done this year. Okay, this is one of the really useful things about quadratics is we can model lots of stuff that happens in the real world. So on this one, it says the height h of t in feet of a weeping willow firework display, t seconds after having been launched at 64 feet per second from a height of 80 feet, an 80-foot high rooftop, is given by that stuff right there. Okay. Crew, here's the cool part. Do we care about all the words?
No.
Nope. You tell me. I'm going to highlight something here. What's the most important thing of what I read? The function right here. That's the most important. Okay. We need to know that. Once we have that, then we can figure out everything else. Now, everything else is written in a little bit of a code, but we recognize some words here. When will it reach its maximum height? And what is its maximum height? So think about what's going on here. And again, this is not a trivial point. Would you draw a set of axes? This is no longer the x-axis. We're not going to find an x-coordinate of the x-coordinate of the vertex. What is this label? Don't say anything out loud. Let everybody figure out what it is. What's taking the place of x's in this problem? Raise your hand if you know. Okay, Luke. T, very good. T, and it's in seconds. Excellent. What's taking the place of y's in this problem? I'm just going to call on somebody. Lizzie? Height. Okay. That's h of t, and that is in feet. Now, it does not ask us to graph this, but you can imagine what this would look like because this is negative, and there's a reason why all these numbers are what they are, but they launched it from a rooftop, maybe an apartment building or something like that, and this firework would go up, and then it would come down. What they're asking us for is, hey, can you tell us how long did it take it to reach its maximum height, and how high would it go? The same thing that everybody that watches a fireworks show wonders. Man, that took a long time to get up there. I wonder how long it was in the air, and I wonder how high that was when it exploded. So that does not surprise me at all. Okay? So what's the t-coordinate of the vertex? Negative b, opposite of b, over 2 times a, which is 2. Do not say anything out loud. That should have a label on it. You should know what that is. And if you don't know instantly what it is, you should be able to think about it for just a second and go, oh yeah, we're not using x coordinates anymore. Somebody want to raise their hand and tell us what this is? What does 2 mean in the context of the problem? Keely? Yep, it's t or seconds. 2 seconds. Took 2 seconds to get to its maximum height. Well, if we've got an equation that will tell us how high it is based on how long it's been in the air, we're going to take this and we're going to plug it in there. So we're going to find h of 2. So we plug that in. Negative 16, 2 squared, plus 64 times 2, plus 80. Probably going to throw that in the calculator. Oh, is that right? Oh, plus 80. There we go. Yeah, that looks much better. $144.
Yep.
Label. Don't let somebody else do the thinking for you. Label it. Mason, is that a question, or do you want to tell us what the label is?
No, I wanted to tell you that.
Oh, hold on. Let's stick with the problem. What's the label?
Oh, well, the label is 144 feet.
It's feet, okay? Takes 2 seconds to get to its maximum height, and at its maximum, it's 144 feet off the ground. Okay, any questions there? All right, I'm going to stop this because we don't want to record